Okay, welcome to week 3. We're going to talk about sampling and study designs this week. So we're going to start with lesson 10. We're going to focus here on sampling. So we're going to talk about samples, populations, and inferences. So to start with, we need some jargon. The population is the complete set of everything in a group of interest. So maybe I might be interested in all Oregonians, or all U.S. adults that are, especially lately, registered to vote in the 2020 presidential election. A lot of times it's difficult to obtain information on the entire population, so we take what we call a sample. A sample is a subset. So it is denoted with a lowercase n. The population has an uppercase N, and the sample size can be, it's usually less than the population size, but it can be equal. In fact, when it's equal, it's called a census. Granted, the U.S. Census is not a true census. It tries to be, but a census is when you sample the entire population. So statistical inference, the idea is you have a question about the population, so you collect information on a sample and use the results from your sample to make a statement about the population. So it is very, very much a cycle here. You start off with a question you want to know, say, the average weight of an African elephant. Granted, it's probably going to be very difficult to obtain the weights of all African elephants in the world, or even in Africa. So take a random sample of African elephants. So there we have here. And if I want to estimate the average for the population, I'm going to use the average from the sample to help estimate. And then once I have that average from the sample, I might make a statement about the parameter. So this is a Greek letter mu. And so be careful, it is not an M. We will jump on that every time. And that would be the mean for the population. So here, I'm a big fan of alliterations. So you have population parameters and sample statistics, right? So P, S, S. I'm a big fan. So a population parameter is a characteristic from the population that we're interested in. So this could be the average height of all Oregonians. This could be the average tuition cost of all OSU freshmen. Typically, this is an unknown value that we try to estimate. You'll see here population parameters. So this is the Greek letter theta. This is a generic, like if I'm just trying to estimate a parameter but I'm not specifying which, we use this Greek letter theta. If we're looking at a population proportion, it's the letter P. And if it's a mean, we use the Greek letter mu. And if we're talking about spread and standard deviation, it'll be sigma, the Greek letter sigma. So things to note, if it's a Greek letter, most of the time it's going to be talking about a population parameter. Versus if I'm talking about a sample statistic, this is a characteristic, typically the same characteristic, but from the sample. So we use the sample mean to estimate the population mean, that kind of idea. So in general, if there's a hat involved, this means this was calculated or estimated using sample data. So theta hat, P hat, X bar, and S. So note, for the most part, we're not going to have Greek letters in here. Yes, there's that theta, but it's got a hat. But if it has a hat or a bar, most of the time you can safely assume, okay, this is a sample statistic. Okay, so here's an example. We're looking at, there's a website, they claim 13% of Americans are left-handed. This is really, really important information to know. For, let's say, a university, they might be interested in having enough left-handed desks for their students, so they need to have an idea of how many left-handed students or proportion of left-handed students they have. So they go ahead to investigate this. they have they take the classroom next to the facilities office, which is hosting engineering classes during one of the class periods, so particular day, particular time. The facilities worker walks around the room and counts. There are 94 people in the class. 19 of them are left-handed. So now we want to ask a couple of questions here. What is the population and the parameter? So the population is what bigger group of people do we want to make a statement about? Because we're interested in making a statement about left-handedness. But we are looking at all students at this particular university. You might want to be more specific and maybe say all engineering students. It's problematic they only sampled engineering students. And then here, so what I'm collecting from each individual. So individual 1, left-handed or right-handed. Individual 2, left-handed or right-handed. This is a categorical variable. So we're looking at a proportion. So my parameter is going to be P equals 0.13. At least this is the claimed proportion. So my sample here, now I need to talk about, well, who is in my data set, who made it in. It's going to be these 94 students. So only the 94 students in the class that day and that time. And then my sample statistic is going to be the proportion I observed in my sample. So P hat, be very cautious, there should be a hat, is 19 over 94, is equal to 0.202, or if you translate into percentage, 20.2%. So at least based on this class alone, maybe this particular university needs to be concerned, like if they only make 13% of desks left-handed, they may not have enough left-handed desks, at least not for this classroom. So now we need to get down to what is sampling, why are we doing it, and a lot of it just comes down to collecting information on every individual in the population is difficult if not impossible, and that's why we sample. So sampling, it's that procedure that we use to select individuals from that population to participate in a study. So how do we pick individuals to be in our sample? And why? I might have hinted at it there. So the first, limited resources makes it impossible or close, very difficult to collect data on the entire population. If I went ahead and I said, okay, you have 1 week, collect data on every single OSU student, you're not going to be able to reach every single OSU student in that span of time. The money, the time it would take to actually get this done would not make it feasible. And then 2, and this is our happy place, if sampling is done properly, and we're going to talk about what that means, the results that we see happening in the sample, we can make inferences back to that population. So as long as we have our study designed properly, we can take our sample results and relate them to the population. So the main goal of sampling, well, for starters, it definitely saves a lot of resources from, collecting data on the entire population. So the idea here is we want to draw a sample from the population such that the sample is representative of the population. In other words, we want our sample to be like a mini population. If you were looking at a university, you would want whatever gender demographics in your population to also show up in your sample. You would want to show whatever age demographics are in your population to also show up in the sample. You want your sample to be as close to a mini population, like it represents that population, as possible. And so how do we do that? Because human beings are really, really, really horrible at actually drawing something that's truly representative sometimes. randomly select individuals. So randomly select individuals that will be in your sample. Okay, so what we mean by random sampling. Random sampling, it uses a random mechanism such as a random number generator or a random number table if you have a really old copy of a stats book. It's really old school. Most people don't use those anymore. I did back in the day, but it's been a while. So you use a random mechanism to obtain your sample, and this is so that you can minimize bias. And what we mean by bias is the tendency to systematically favor certain parts of the population over others. This means maybe some parts of the population are overrepresented and some are underrepresented. That it actually happens a lot in medical studies and in medication treatment studies. It can be very problematic. So think of as bias goes up, accuracy goes down. And vice versa. As bias goes down, accuracy goes up. So the first type of random sampling we're going to talk about is simple random sampling. And even though others might start with an S, it's the only one that we abbreviate SRS. If you see SRS, we mean simple random sample. So a simple random sample is when you take a list, like a master list from the population, so you have N, capital N individuals, and you randomly select little n number into your sample. So maybe I have 30,000 OSU students and I have all of them in a list by ID number, and I tell the computer randomly select 100 of them. So it just takes 100. That would be an example of a simple random sample. So the idea, here's my it's a small population, random selection. So it randomly selected 6, 2, and 8. So talking about how we do this, a simple random sample is of n individuals, so that's just how many are in your sample. Of n individuals from the population, that should be a capital N. It's chosen in such a way that every single set of n individuals has an equal chance. So what that means is if I take a random sample of 100 students from 30,000, that 100 students was just as likely to be picked as any other sample of 100 students. That's what that means. So picking a random sample, I hinted that we might use ID numbers, and that's often how we do this. So step 1, assign each individual a unique number. So it could be ID, it could be driver's license, it could be subject 1, 2, 3, as long as they're identifiable. Every individual has a unique name or number. They have their own row. Step 2, use a random number generator to select the numbers. So here's a very small population of 10. So tell the computer, okay, pick, 3 numbers between 1 and 10. And it says, okay, well, 3, 4, and 9. So now I'm going to take 3, 4, and 9. And then I'm going to find these individuals and I'm going to sample them. I'm going to go collect whatever it is I want to collect. So our second type of random sampling is a stratified random sample. And you might notice that it's tempting to abbreviate. Do not abbreviate this one because SRS only is simple random sample. So you use a stratified random sample when you really want to ensure that subpopulations or groups are represented. So for example, maybe I want a sample from a high school. Well, it's going to be really, really important if I'm sampling students to get students from every grade. So in order to guarantee I get students from every grade, I'm going to have 4 different rosters. So like freshman, sophomore, junior, senior. And maybe I'll sample 100 freshmen, 100 sophomore, 100 junior, and 100 seniors. That way I've guaranteed that I have equal representation. Although it doesn't have to be equal representation. If I had twice as many juniors than seniors, I might want to do this instead. That kind of idea. But this is a way to guarantee that you have every single group that you think is important to capture in your sample. So for example here, we have our population. We have green people. So these three are green. All the others are blue. So what we do is we now have two subpopulations. So I randomly sample from the green, and then I randomly sample from the blue. And that's how I get my sample. It ensures that I have people from green and people from blue. And not only that, there's 3 in the green, 6 in the blue. So I randomly sampled 1 from green and 2 from blue. It maintains that same proportions, that there's twice as many blue as green in the sample. So systematic random sample. This is really handy for things like things that are on conveyor belts, manufacturing, things where things come out in order one by one. People walking by, really, really difficult to do this with. But it's the idea, you start at a randomly generated point, and then you collect data on every capital N over little nth item. So maybe I have 30,000 students at OSU. Well, I can take them into a list, and I can take every 100th student until I have a certain number, maybe 200 in my sample. So take every 100 students on that list until I have 200 in my sample. Here, it's a very, very short list. There's 9. We randomly started here, and we decided, okay, well, I'm going to take, every 3. So I take 2, I take 5, I take 8. If I kept going, I would take 11, 14, and so on. So this is really, really handy when you have like a manufacturing line or something like that. Something where there's like an ordered list. So now we're going to go ahead and we're going to figure out, I have 3 different sampling scenarios. One is simple random sample, one is stratified random sample, and one is systematic random sample. And we're going to go ahead and we're going to figure out which is which. So our prompt here, we have a university, and this is a picture from OSU. They want to go ahead, they have 3,000 students living on campus dorms. Who knows, this may not be true, especially with COVID. And they come up with 3 different ways to get a sample of 100 students. So definitely, here's a good place to pause so that when I go through, you're checking your answers. So, A, they go ahead, they get a list of all dorm residents, and they randomly generate a starting point between 1 and 3,000, and then they select every 30th student on that list until they get 100 students. So, suppose they started at 42, then they're going to also take 72, and 102, and 132, and they're going to keep going until they have 100 of these students. And so, since we're taking every 30th student, I'm hoping that this kind of triggers the idea, this is a systematic random sample. Systematic because we have a random starting point, and we're taking every 30th student on this list. So B, they obtain a list of all students living in dorms on campus. So they go ahead, they use software to randomly select a sample of 100 students. And from there, they go ahead and they survey by phone, email, or in person each of the 100 that were selected. So here, it sounds like they have a master list. They have a list of everyone in that population, and they tell the software, pick 100 of them. This should make me think simple random sample, because we just went ahead, took a sample of 100 students. Those 100 students were just as likely to be picked as any other 100 students. So then C. They can take a simple random sample of 20 students from each of the 5 dormitories on campus for a total of 100 students. So the idea here is there are 5 dorms on campus, and it's really, really important that they survey students from each dorm. So in order to make sure each dorm is covered, they go ahead and they randomly select 20 from dorm 1, 20 from dorm 2, 20 from dorm 3, all the way through dorm 5. So even though it says simple random sample, don't let that mislead you. This is a stratified random sample. I'm going to just abbreviate there. Where the strata, so strata means groups, are the dorms. So they grouped them by dorm and then randomly sampled from each dorm. So now that we've sampled, we want to talk about, there are definitely wrong ways to sample. So for example, it's really, really rough when you have a convenient sample. So a convenient sample is a sample where the individuals in your sample are whoever was easiest to get information on. So for example, if I wanted to go ahead and make a statement about all of OSU, so I sample ST201 students, I have easy access to y'all as students. That's not me taking a representative sample. So here, this is volunteer sampling. So volunteer sampling, it's a special case of convenient sampling. It's very, very, so this is the one kind of sampling we have here where the researcher is not picking who participates. The people who participate pick themselves to participate. So this might be they volunteer their response. A lot of times you might see this as an online poll. Yelp, any sort of reviews, Rate My Professor for sure. The idea behind this volunteer sampling, it's problematic because the people most likely to volunteer and to participate in these polls are usually ones that feel very strongly. Like if you have a professor that you feel like, wow, that was so run-of-the-mill, this person was thoroughly okay, you're probably not going to go out of your way to make sure that you rate them on Rate My Professors. You're much more likely to go on there if you had a really bad experience. Also, some folks with really good experiences, but people are way more likely to go on there with a bad experience. So, same with Yelp. I don't think I've ever gone out of my way to give a mediocre, like, oh yeah, this was okay, review. So, very problematic. So, when you get data from these poor sampling designs, it really, really limits what we can say about the results. It usually biases our results, so it makes them inaccurate for the population of interest. So a lot of times this will lead to us overestimating or underestimating certain characteristics. So I might have been trying to estimate, I don't know, the data from these poor sampling designs, they're very likely to bias our results, which means they're likely to make our results inaccurate. So this can lead to overestimating or underestimating a mean or a proportion for the population because we have a sample that doesn't represent the population. And that's what's problematic. We can't make statements about the population when our sample doesn't represent the population. So we have a few forms of bias here. So undercoverage bias, and we're going to go into these three types of bias a little bit more. They each get their own slide. So this is where you leave out or underrepresent certain subpopulations. So maybe I am sampling from a high school and I just forgot to sample any first years. That's really problematic. There's non-response bias, which is really common. So this can be for a number of reasons. It could be because you selected someone to be in your study, but then you couldn't reach them, so they couldn't participate. Or you reached them, and for any reason, they choose not to participate. So then you get non-response bias. And then response bias. So this one doesn't have necessarily to do, this is the one that's after sample is selected. So you've selected your sample, whoever is going to be in your sample is already in there. And these are things that could influence the results and make them inaccurate. So it could be the type of question you're asking, the order of the questions, the wording in the questions. It could be who is asking the questions. So there are a lot of issues that can make your results, especially from a survey, inaccurate. So undercoverage bias, that's going to happen when you have some groups or even just one group in the population, they're left out or seriously underrepresented. So for example, I am picking on my friend Namdi here. So Namdi wants to find out how much OSU students spend on pizza this month. So they randomly select 50 male students from dorms on campus to survey. So give this a second, think, why could this be problematic? So looking back, think about who the population is. They're looking at all OSU students, right? So they are missing students that don't live in dorms. And they're missing students that aren't male. This is super problematic. So here, this is probably not the worst if you want your population to be male students at the dorms at OSU. But if you want them to be all OSU students need to have potentially been selected. If they aren't even in the running to be selected for the sample, that's a problem. So non-response bias. So suppose this is any time an individual is selected by the researcher to participate, and for any reason they can't be contacted or they refuse. So that can be problematic. That happens a lot with surveys, actually. So I'm picking on Namdi again. It's going to be Namdi and pizza for these three. So Namdi wants to find out how much OSU students spend on pizza this month. So they randomly select 50 OSU students to survey. Out of those selected, only 34 agree to participate. We have 16 missing. It's problematic because a lot of the time you cannot just assume that this 16 or however many chose not to participate are identical to the people who do. Even look at something like the census being taken. The non-response bias that happens when people are delivering the census is not at random. People aren't all equally likely to decline to participate, which makes this very problematic in actually determining that you have a representative sample. And then response bias, this one is a little more, it can be a lot more things. So it occurs after the sample is already selected and everybody who's going to be in the sample already isn't there. But it's when an individual does not answer accurately or honestly for any reason. So it could be malicious. They could be liars. But it could be, innocent. They could forget. They could, round. They could there are a lot of reasons people may not give accurate answers. So Namdi, again, still stuck on pizza. They go ahead, they take a random sample of 50 OSU students to survey. So suppose some students don't remember how much they spent, so they can't give an accurate answer. Maybe some students are embarrassed. Maybe they spent a lot on pizza and they don't want to share that real number. A lot of times, humans especially, we have a tendency to round. So if I spent $13.95 on pizza, I'm very likely to say I spent $15. I'm more likely to say I spent $15 than $13.95. So humans tend to round. And then absolutely the wording of the question and the wording or options for the answers can make a huge difference. So he could have written very, very loaded question, like, it's been shown that the fat in pizza causes X disease. I don't know. How much money would you say you've spent on pizza this month? That might really make people hesitate. So it's very, very easy to get inaccurate responses. I know the census, they ask folks not just who's living in the house, but like how much people make. People have a lot of reasons that they don't want to tell a stranger how much money they make. There are a lot of reasons for that. So keep in mind, some of it's intentional, but a lot of it's just people either don't feel comfortable or it's not intentional. So one of my favorite examples, so this is Calvin and Hobbes. I didn't give them the credit. Y'all might recognize. So this guy, he's going ahead and he's saying, hey, I'm filling out a reader survey for Chewing Magazine. See, they asked how much money I spend on gum each week, so I wrote $500, which is a lot for gum. For my age, I put 43. And when they asked what my favorite flavor is, I wrote garlic/curry. And then here they're kind of laughing, and this magazine should have some amusing ads soon. I love messing with data. So it is possible people can maliciously, like intentionally mislead. And it happens, but sometimes people aren't necessarily malicious when they do it. Okay, so here's an example here. We have a researcher. They would like to sample the length of certain species of fish in a large lake. So they have one lake they're interested in. They want to know the length, probably the average length of all that type of fish in that lake. So to collect fish, they randomly select different entrance points. So maybe I have a lake here, and they randomly select here, and here. I don't know. Hopefully more than 3. And they wade into the lake. So they walk in, and they're in here, and they have a small mesh net. I'm not going to quit my day job anytime soon. So they go ahead, they catch some fish from that place where they're standing, and they record the lengths of those fish, and then they return them to the lake. So what are some possible issues with this scheme? I'm going to throw out a hint. There are issues with this. Yes, they use random sampling to locate the spots, but it's not like they could have picked the middle of the lake, right? And that's part of it. They could only pick parts of the lake that they could wade in. That's part of it. So the estimate is biased to fish close to the shore. The estimate is biased towards larger fish that could be caught in a net. Absolutely. I would argue both of those things are true. You could only pick spots where the researcher could wade in, where they could walk, stand in the lake. And the fish had to be big enough to be caught in this net. So that might not be very big, but they still had to be at least a certain size. A lot of times it's really problematic, wild animals in general, catching them, because if you want to say determine, I don't know, the average weight of snow leopards in an area. Good luck, like, catching all of them. You can't catch all of them, but not all snow leopards are equally likely to be caught. Some are real sneaky. They're never ever going to let you catch them. But funny enough, some animals, wild animals, when you trap, like using bait, they really, really like the bait. So you catch that animal over and over, to the point where scientists kind of shake their head and like, oh, it's this one again. So keep in mind, wild animals, really, really hard to get any sort of truly random sample from the population. So, I don't know, this sounds super appropriate for this upcoming presidential election coming up. Caution of sampling and surveys. So, just because you have a very large sample size does not mean you will always have better results, especially if that large sample is biased in how you took it. So, a few examples. Alf Landon, because how many of us have heard of Alf Landon? They were predicted to win the presidential election back in 1936. And clearly they didn't win. Actually, FDR won. And they had a huge sample size, 2.4 million. But FDR, so Franklin Delano Roosevelt, won the presidential election that year. More recently, an if year. 2016, there was survey after survey that really put Hillary Clinton up ahead in the polls, and they argue that Trump won. I would like to point out, though, a lot of the polls were for the popular vote, like who would win the popular vote, and she did still win the popular vote. Whether or not the Electoral College, that's a whole other thing. So it's so important to have a random representative sample. It's possible to have representative without random, but it's much, much harder. The easiest way is to have a random sample. So some caution, the way you contact folks and who contacts them, super, super important. Suppose you might want to have a survey about how people feel about defunding the police on campus. Well, if the people contacting students is a police officer, they're very likely to respond to them differently than if the person reaching out to them was not. Totally different results. Seriously. So just some other examples, like this is showing the Vietnam draft, and the idea is, hey, they should be, selecting by birth month, like equally likely. And if you look here, this is a bar chart. It does not look like it was equally likely. And there should be a button here, a link, if you have this slideshow open and going. And they're just more statistical issues there. So another example was in 2000. I want to say it was George W. Bush. No. Yes. It's been a while. Yeah. Yeah. So why is the butterfly ballot in Palm Beach? So this is a butterfly ballot. Why is it poorly designed? So if y'all have had a chance to maybe do an early voter, get your ballot in early, you might notice that usually the top two choices are the Republican and Democratic candidates. Almost always. It's very rare that the first two, the top two, are not the Democratic and Republican candidates. The other people, they kind of get squashed really, really down low. So, looking here, we have George Bush, we have Al Gore. But if you look, the second highest one is this Pat Buchanan. And in this particular area, Palm Beach, way more people voted for Pat Buchanan than they anticipated. And it was because it's the second highest. So here's the top one, here's the second highest one. So people voted for this one without realizing what they wanted. A lot of them, not all of them, was actually right here. So very interesting how you display your answers your answer options can absolutely influence but they're never going to start putting the candidates in random order. They should, but they're not going to, and I'm sorry. So some more cautions. We have a survey that was from summer 2009, and they were looking at opinion polls, specifically looking at popularity for a public option healthcare. So we have 4 different polls. We have a poll by Times/CBS News. We have one by Time, we have one by Pew, and we have one by Fox News. And we have very, very different results, right? Part of this is important because what is their definition of public option healthcare? And we have 4 different definitions. And then I'm going to talk a little bit about this right here, but let me display the questions. So when you look at survey results like this, there are some really important questions to ask. So it's really important to ask, well, how were these people sampled? Is this a volunteer sample? Could there be sampling bias or non-response bias? What's the margin of error? So this says plus or minus 3. So this is saying, hey, Times says we think it's 63 to 69%. So still more than half. But if you look here, 49% to 55%, this is less than half and this is more than half. That's really misleading if you just report 52%. This plus or minus 3% means, hey, we actually have a range of values we think it's in. So absolutely, definitely pay attention to that. Is the poll time sensitive? Like, when was it offered? It's going to get very different results if it's only available for one night and not in the morning or something like that. Could you have an effect based on how the questions are ordered, how they're asked, what type of answer options do they have? Can they write in their answer, or do they have to pick from a certain list of answers? Is there anything can we assume the respondents are giving truthful answers? Is there a reason we should not assume this? Definitely ambiguous terms, super, super important. I really can't stress enough. So if you're if you're familiar with English, we have this, double negatives. So don't not do that. It's supposed to mean, oh, do that. Well, I had a class where they gave us something like 5 or 6 double negatives in one sentence. And it made it very, very difficult to actually tell what the question was asking. And it made it so that a lot of us gave the opposite answer of what we intended. Another really famous one fairly recently was Prop 8 in California. They were talking, Prop 8 was a ban on same-sex marriage. And the way it was worded, a lot of people who meant to vote against the ban voted for it because they misunderstood how it was worded. And then another one, super important, is who's paying for the research, right? Because it's super important to keep in mind, maybe I have a different opinion about Pew's research versus Fox News' research, right? Who is paying for it? Who benefits? That's super important question. So here, after the 2016 presidential debates, super creepy, Trump kind of lurking behind Clinton. Oof. Suppose cable news outlets asked their viewers to take online poll regarding, Okay, so rewind 4 years, the last set of presidential debates, so Trump and Hillary Clinton, and the cable news outlets, they go ahead, they ask their viewers, okay, you just watched the debates, take our online poll regarding who they want. So what type of sampling method is this? So things to consider is, did they take a simple random sample? No, I don't think they had a list of people. There weren't different groups they felt was really important. I would argue this is a convenient sample. And why? It's a convenient sample because they took people, they asked people at the end, like who are watching their show, hey, could you do this? They picked their viewers, the people who were conveniently right there. They didn't go get a list of people and select. They let people volunteer themselves. So this is a convenient sample. Specifically, I would argue it's a volunteer sample because anybody who wasn't watching the debates on this particular channel probably won't see the invitation to participate and probably won't. So the only people eligible to participate are people who watched this news show at that time and probably had internet. So that's pretty important as well. So now we have a Gallup poll. They're pretty big in the polling industry as well. So specifically, a disposable diaper company asked, and here's this big, long, wordy question. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers and forego convenience? So what type of bias do we think people are worried about? Okay, so for this problem doesn't address at all how folks are sampled. So, undercoverage bias, this is a form of sampling bias. So, no, we're not worried that specific groups of people are being left out here. And here, non-response bias happens once we select people to be in our sample and then they choose not to respond. That doesn't seem to be the issue here. I would definitely argue, so this says question wording bias. This is another way to say response bias. So here, this is a loaded question. It's saying, hey, we make up 2% of the trash, but these other things make up a bigger percent. Given this, do you think it's fair? Oh my goodness, the word fair. To ban disposable diapers and forego convenience. So that is far from a neutral question. If your question is not worded neutrally, you have a response bias problem. So that's it for Lesson 10. Join us for Lesson 11. Hope to hear from you soon.